Hey there, I'm sure you know what prime factorization is. For a number like 4, you would have 2 into 2. For a number like 15, you would have 3 into 5. For 27, you have 3 times 3 times 3. Writing any number as a product of its prime factors is called prime factorization. For us, this is a very useful tool to figure out the cube roots of numbers. Let's see how. So 4 is 2 times 2 and 27 is 3 times 3 times 3. But 4 is also 2 square and 27 is 3 cube. The idea of a square is that you take the same number and multiply 2 of its copies. The idea of a cube is to take the number and multiply 3 of its copies. Similarly, 6 square is 6 times 6. When you square a number, you get 2 copies of the same number and you multiply both the numbers. But 6 is also 2 times 3, which means 6 square would also be 2 times 3 times 2 times 3, which means every prime factor appears twice. There are 2 2's and 2 3's when you square a number. Similarly, when you cube a number, 6 cube, you get every prime factor 3 times. So you get 3 2's and you get 3 3's. 2 times 3 is 6, 2 times 3 is 6, 2 times 3 is 6. 6 cube, as we know, is the same number multiplied 3 times. And the reverse operation to a square is what we call as a square root. Just like addition and subtraction are opposite operations and multiplication and division are opposite operations, similarly in a square root, you combine the 2 copies into one number. So 2 2's becomes one single 2. 4 is 2 square, but the square root of 4 is 2. Similarly, for the cube root of 27, you have 3 3's and you combine all the 3's into one 3. Let's see more examples. If you had to find the cube root of 6 cube, expand this 6 cube as 2 times 2 times 2 times 3 times 3 times 3, and you would group every 3 prime factors as one number. Cube root of 6 cube would be 2 times 3, and that will be 6. But what if the number was 216? How would you find it? When it was 6 cube, 6 is 2 times 3 and you can easily expand it. That's where prime factorization comes in. To find the cube root of number like 216, step 1, find the prime factors. So let's prime factorize 216. So we'll start with 2, that'll give us 108, and then we have another 2, that'll give us 54, 2 again, that's going to give us 27, 3 now, 3 9s is 27, okay, 3 3 is 9, 3 1s is 3. So here we have all the prime factors. And the second step is combine into groups of 3. Then that gives us the cube root of 216 would be 2 into 3. And finally, step 3 is multiply the group numbers, and that would give us 6. So that's the way to find the cube root of any number, if it is applicable, because sometimes you may not be able to find the groups of 3, and that means that number does not have an integer cube root. Let's take some examples. Let's try and find the cube root of these numbers. We'll start with 400. Before that, let's recall the 3 steps. The first step is find the prime factors and then combine them into group of 3 and then multiply the group numbers. So let's start with finding the prime factors. 400, it's an even number, so 2 would be a divisor. 200, again 2 would be a divisor, 200, divisible by 2 again, so 50, 25, now divisible by 5, so 5 5 is 25, 5 1s 5. Awesome. So these are our prime factors. We have 2 times 2 times 2 times 2 times 5 times 5. The next step is to combine into groups of 3. Now I see only one group of 3 here, which is a set of 2's, and we have only 1 2 left over and we have 2 5's. So this, as I told you before, means that 400 does not have an integer cube root. We cannot find an integer cube root for 400. We might be able to find another type of cube root, but not an integer cube root. So that's that. Let's go to the next one. 2744. Again, let's start with the prime factors. 2744, even number, so 2. 1372, again even. 686, 343. Now 343 is interesting because 343 is 7 cube. So I recommend you memorize the cubes of at least the first 15 natural numbers. So 1 cube till 15 cube, because that is going to be very handy for you to figure out the prime factors and for many other use cases. So that tells us 7 square times 7 is 343. So 7 times 49 is 343. Now we know that 7 square is 49, so 7 times 7 is 49 and 7 ones is 7. and these are our prime factors this time. We have 2 times 2 times 2 times, 7 times 7 times 7, and clearly we have two sets of groups of 3. So cube root of 2744 would be equal to 2 times 7. So this is 2 combined into 1, and then 7 combined into 1. And then we multiply the group numbers. So 2 times 7 is 14. This means 14 cube gives you 2744. Let's go to the next one. 10,648. Starting with the prime factors. 10,648 even number. 2 times 5324. So that next 2622. 2 times 1331. 1331 is again an interesting number because 11 cube gives you 1331. 11 cube times 11 cube you get by multiplying 11 square times 11. So 11 times 121 is 1331. So 11 times 11 is 121 and 11 ones is 11. So we have 2 times 2 times 2 times 11 times 11 times 11. Next step, combine into groups of 3. So 2 times 11 and then multiply them is 22. So 22 cube gives you 10,648. Great, we've solved all the questions. Here's an interesting bonus question. If A, B and C are prime numbers, under what conditions would A times B times C the whole square be a perfect cube? Justify your answer using what you know about prime factorization of perfect cubes. I'll see you next time.